Hello, this is Mrs. Decker, and this is Objective 1B on counting particles. So in this lesson, we will learn how to identify and calculate the number of protons, electrons, and neutrons in an atom, ion, or isotope given sufficient evidence. So before we go ahead and jump into 1B, we're going to do a quick review of some of the information we learned in 1A. So, if we're looking at phosphorus, if you have a periodic table, you can see that the atomic number for phosphorus is 15, and the average atomic mass for phosphorus is 30.97, and this question is asking us for the mass number, so we're going to round that up to 31. Now for sodium 24, remember the way this is written, the 24 is the mass number. So we would need a periodic table to look for sodium, and we would see that the atomic number for sodium is 11. That means that there will be 11 protons. There's nothing here to tell us that it's not neutral, so we're going to assume that it is neutral. And so that means we have 11 electrons. And then to calculate number of neutrons, we would do 24 minus 11, which gives us 13 neutrons. And the last one here, aluminum 3+. The 3+ tells us that this is an ion, and since it is a positive ion, that means it has lost electrons. So if we look for aluminum on the periodic table, we see that it has 13 protons. And since we have a positive ion, that means it has lost electrons. And since its charge is +3, that means it has lost 3 electrons. So it has 10 electrons. And then from the periodic table, we see that the average atomic mass is 26.98. So we're going to round that up to 27. Subtract 13 to get the number of neutrons, which is 14 neutrons. Okay, so for Objective 1B, you will be given tables like this that you will need to fill out. So each line will have some information about a specific atom, ion, or isotope, and you will need to use the information given, plus possibly the periodic table to figure out the rest of the information and fill it in. So it's important to note that not all of the tables you see will be in this same order. So you need to pay attention to what the heading is and make sure you're filling in the correct information where it belongs. Okay, so our first line here, we have the name of the isotope, which is nickel 59. So if we look at the periodic table and we look for nickel, we find that its atomic number is 28. And the mass number from the periodic table, the average atomic mass, is 58.69. But we're given the mass number here under the name of the isotope. So we want to use that mass to fill out the information for this table. So the mass number is 59. So now if you remember, the atomic number tells us the number of protons in an element. So that would mean that nickel has 28 protons. There's nothing here to tell us that this is an ion, so we are assuming it is neutral, which means that it will also have 28 electrons. Now, to find the number of neutrons, we're going to do the mass number, 59, minus the atomic number, which is 28, so that gives us 31 neutrons. And then the last thing we want to do here is write the symbolic isotope notation. So the symbol is nickel, and remember when we write this, we're going to write the atomic number on the bottom, so that would be 28, and the mass number on the top, which is 59. Okay, so for the next line, we have the number of protons and the number of neutrons. So remember, the number of protons will also tell us the atomic number of the element. So that is atomic number 34, which is selenium. Okay, and there is a mass for selenium on the periodic table. However, remember we want to use the information that's given to us in the table. So the number of protons is 34 and the number of neutrons is 44. So we want to add those up to get the mass number for this particular element, which is 78. And again, it's a neutral element, so we will have 34 electrons as well. The mass number we just calculated to be 78. So the symbol for selenium is Se, and on the bottom we write the atomic number, which is 34, and on the top the mass number, which is 78. Okay, so for the next one we have Kr. Kr stands for krypton. Okay, and the 36 on the bottom is the atomic number. And the 85 on the top is the mass number. So we write the mass number there. We also have to add the mass number to the name of our isotope. So the atomic number also tells us the number of protons, which is 36. Again, this is a neutral atom, so electrons are 36. And to find the number of neutrons, we would do 85 minus 36, which gives us 49 for the number of neutrons. Okay, and for the last line on this chart, we have an atomic number of 12 and a mass number of 25. So looking at the periodic table, we can see that atomic number 12 is magnesium, and the mass number of this one is 25. So atomic number tells us number of protons, which is 12. This is a neutral atom, so there are also 12 electrons. To find the number of neutrons, we are going to do 25 minus 12, which gives us 13 neutrons. And then we just have to finish up with our symbolic isotope notation. So the symbol for magnesium is Mg, our atomic number is 12, our mass number is 25. So it's important to remember when you're filling out these charts, you want to pull the number of neutrons or the mass number from the information that is given in the chart already. Unless, of course, it's not there, then you'll refer to the periodic table. Okay, so in this chart, we're going to look at how the information differs between isotopes. So our first line is cobalt-58. Our second line is cobalt-59. So these two are going to be isotopes of each other. So let's fill out cobalt-58. If you look at the periodic table, cobalt has an atomic number of 27. The mass number here is given is 58. So number of protons is 27. Number of electrons is also 27 because this is a neutral atom. And to figure out number of neutrons, we will do 58 minus 27, which is going to give us 31 neutrons. Okay, so let's fill out the symbolic isotope notation. The symbol for cobalt is CO. So we're going to put the atomic number, 27, on the bottom, and the mass number, 58, on the top. So now, let's complete the line for cobalt-59. So, cobalt is still the same element, which means it will still have the same atomic number of 27. The mass number for this one, though, will be 59. So, protons will still be 27. Electrons will still be 27. To find the number of neutrons here, we're going to do the mass number, which is now 59, minus 27. So the number of neutrons for this isotope is going to be 32. So let's fill out symbolic isotope notation. So the symbol is CO. Atomic number is the same, 27. Mass number for this one is 59. So if we look, these two are isotopes of each other. They're the same element, So they have the same atomic number and same number of protons as each other. The number of neutrons and therefore the mass number is different. Okay, let's look at the next line. It says atomic number is 15. So that is phosphorus. And we need to find our mass number before we write it. So we have an atomic number of 15, which means the number of protons is 15. Again, it's a neutral atom, so number of electrons is also going to be 15. We're given our number of neutrons, so to find the mass number, we're going to do the number of protons plus the number of neutrons, which is 30. Okay. So then we just fill out our last box. So the symbol is capital P, atomic number on the bottom, which is 15, mass number on the top, which is 30. So if we look at our last line here, it has a number of protons at 15, which the number of protons would also be the atomic number. So if we look, this one is also phosphorus. So our number of electrons is also going to be 15. And here we see that our number of neutrons is 16. So to get the mass number for this one, we're going to do 15 plus 16, which gives us 31. So we have a mass number of 31. So still our capital P, still 15 for the atomic number. Mass number for this one is 31. So these two are also isotopes of each other. So they have the same atomic number, same number of protons, different number of neutrons. Okay, so the final chart we're going to look at in this lesson is going to focus on ions. So for our first line, we have an atomic number of 8. So if we look up number 8 on the periodic table, that is oxygen. So number of protons is also 8. It tells us that there are 10 electrons, and we need to find the number of neutrons. Since that information isn't given here, we're going to look at the periodic table, and you can see on the periodic table that the mass of oxygen is 15.99. So we're going to round that up to 16. So we're going to write our mass number as 16. So to find the number of neutrons, we would do 16 minus 8, which gives us 8. So now we're going to write our symbolic isotope notation. So the symbol for oxygen is capital O. Our atomic number is 8. Our mass number is 16. But we're not done because here we have a number of electrons at 10, which does not match the number of protons, which means that this is an ion. So remember, electrons have a negative charge. So if we have gained electrons, and if we have 10 electrons, that means this oxygen has gained 2 electrons. That means the overall charge of the atom is going to be negative 2. So it's important for you to recognize that this element has a different number of electrons from the number of protons, which means that it's an ion, so you will have to add that to the isotope notation. Okay. So now if we look at the next line, we see that the atomic number is also 8. So it is, again, oxygen. Again, the information is not given for the mass because we don't have the mass number or the number of neutrons, so we'll use 16 again from the periodic table. The number of protons will be 8 because that's the atomic number. So again, neutrons will be 8 because we're using the same mass. And now the symbolic isotope notation, we write the capital O, the atomic number on the bottom, and the mass number on the top. Okay, and now the electrons here are equal to the number of protons, so this is not an ion. So now we're done with this line. Okay, and the next line, Mg, stands for magnesium. So we have our atomic number of 12 and our mass number of 25. Okay. So the number of protons is equal to the atomic number. We have 12. There is nothing here to tell us that this is an ion, so the number of electrons should be the same as the number of protons, which is 12. And then to find the number of neutrons, you do the mass number minus number of protons, which gives us 13. Okay, so now the only thing that will be different here is the number of electrons, because it's magnesium, which means the atomic number and number of protons is the same, and the mass numbers for both of these are the same. So that means the neutrons will be the same as well. Okay, so we'll have 12 protons and 13 electrons because the atomic number is 12 and the mass number is 25. So here we have a +2 charge up in the top right-hand corner, which means that the element has lost 2 electrons. So if it started off with 12 electrons and it lost 2, that means it's now down to 10. So there's some practice for you to work on in the next page of your packet. So go ahead and do that and let me know if you have any questions.